we are trying to define the centroid. We have an area A, and this area has, let's suppose, centroid at point C. In order to mathematically define the centroid, we define first of all our x and y axis. Let's suppose this is our x-axis, and we suppose let this to be our y-axis. We call this as x-axis, and we suppose let this to be our y-axis. If this is our x-axis and this is our y-axis, then the mathematical definition for the centroid is the centroids from the x-axis. The centroid is at some distance. That is, in order to move to the centroid from the x-axis, you have to follow x-axis, and along y-axis it will have some y coordinate. It will have some y coordinate. The x and y coordinates are defined as, the x coordinate of the centroid C is defined as x bar, and the y coordinate is defined as y bar, such that as far as this x bar is concerned, x bar is equal integral x dA divided by integral dA. These are area integrals. What does this mean? I'm starting from the yesterday's lecture. Yesterday we found that there is a need of centroid. As far as the centroid of a plane area is concerned, I'm repeating, we have an area A. We say let its centroid be at point C, such that the x coordinate of the centroid is x bar and y coordinate of the centroid is y bar. Now the question is, how much is the value of this x bar and how much is the value of y bar? What are the x and y coordinates of the centroid of any plane area? In order to find that, what we do, we take a very small area. In this total area A, we define a very small area. And say, let this area has a very small area called as dA. This dA is very small, such that the center of this dA is at a distance. X from the y-axis, and is at a distance y from the x-axis, So in order to find the centroid of the total area A, we have used a very small area dA in this total area A, and we say let the center of this small area dA be at a distance x from the y-axis and be at a distance y from the x-axis. Okay, then the x coordinate of the centroid is equal to x coordinate of the small area dA multiplied by dA, x into dA, and this integration, this is area integral x dA divided by the integral dA. As far as integral dA is concerned, this integral dA is, by the way, equal total area A. Okay. In the same way, we define the y coordinate of the area as, y coordinate of the centroid as integral y dA divided by integral dA. Integral y dA divided by integral dA. This is the y coordinate of the centroid. It means if we are given any geometrical figure, if you have any area A, if you have some area A, and you are asked where is the centroid of this area, find the centroid of this area. What you do, you say, in order to find the centroid of this area, we say let the centroid of this area be at point C. Okay, before you find out the x and y coordinate of the centroid, define your coordinate axis. That's very important. So define your coordinate axis first. Let's suppose that this is our x-axis. Let's suppose that this is our y-axis. As far as x and y axis are concerned, x and y axis can be within the body itself, within the area itself, or they can be outside the area. Okay, it doesn't matter where you define your x and y axis. Now, before you define the x and y coordinate of the centroid, we have to take a very small area and say its area is, say for example, this area is very small, it's equal to dA. Okay, and the center of this, and assume that the center of the small area dA is at a distance, x, is having some coordinate with respect to x and y axis, and say its x coordinate is equal to x, and the y coordinate of the center of this small area dA is, say for example, y. Okay, then we define the x and y coordinates of the centroid as, we define x and y coordinates of the centroid as, we say the x coordinate of the centroid is x bar and the y coordinate of the centroid is y bar, such that x bar is defined as x coordinate of the centroid and y bar is defined as y coordinate of the centroid of the total area A, such that we define x bar as, x bar is equal to integral x into dA, integral x dA divided by integral dA. And we define the y coordinate of centroid as, integral y dA divided by integral dA. Okay, this is how we define the x and y coordinates of the centroid. Now let's apply these formulas on finding the centroid of some given geometrical figures. That is, let's suppose that we have a geometrical figure like a rectangle. Let's try to find the centroid of a rectangle. That is, let's suppose we have a geometrical figure in the form of a rectangle, such that the width of this rectangle, is given as b, and the height of the rectangle is also given to us. And we say height of the rectangle is h and width of the rectangle is, say for example, b. Okay, and we are asked, where is the centroid of this area? Again, before you define the centroid, what we have to do, we have to define our geometrical axis. Okay, we have to define our x-axis and y-axis. You can define your x-axis outside this body, no problem. You can define your x and y-axis, your coordinate system, well on the sides or the boundaries of this area, no issues at all. You can solve it both ways. The easiest way is you take one of the side as x-axis. This is easiest way of doing it. It requires less calculations. And another side you take as your y side. Okay, so we say, we define, let this axis be our x-axis and let this axis be our y-axis. This is done. Okay, so this is what we did. We had an area. First we defined our x-axis and y-axis. Then the step number 2 is dividing this area into small areas, okay, small strips. So let's take a very small area out of it. That is, let's divide this area into small areas. Let me take a small area element, and let's suppose the area element is, like this. Let me take a very small area element, small area. Let me take a very small area, and I will be calling this as, this is a very small area. I will be calling this small area as dA. Okay. see, there are two ways of writing an area element. Some of you can argue, instead of drawing an area element like this parallel to x-axis, we can draw an area element parallel to y-axis. That's absolutely right, no problem with it. I will show you both ways of doing it. With this area element, we will get the y coordinate. With this area element, we'll get the x coordinate, as I will show you. Okay, so we had an area, given area, and out of this area, we have to find its centroid. Before we find the centroid, we defined our x-axis and y-axis, and we defined a very small area, that is dA. As far as this dA is concerned, let's suppose, as far as this dA is concerned, this dA is a very small rectangle. This is a small rectangle. As far as the small rectangle is concerned, the width of this rectangle is b, and as far as its height is concerned, it has a very small thickness. Okay, it has a very small thickness. Let me say that its thickness is very small. Its thickness is very small. Let's call this thickness as dy. Okay, therefore we can write, as far as dA is equal to, as far as we can write here, as far as our dA is concerned, the dA that we have selected, small area, it's a small rectangle, its area will be equal b multiplied by dy. Okay, that's width multiplied by its height. Okay, this is what we had discussed here. Divide it into small areas. Now let's suppose the center of this rectangle is at a distance, is at some distance from y-axis and the x-axis. Okay, so let's suppose this is the center of this rectangle. Okay, this is the center of this rectangle, and this center of the rectangle is at some distance from the x-axis. Let's call this as our, let's say that this distance is equal to, we have to call this distance from the previous argument, we have to say that its center is at a distance y from the neutral, from x-axis. Okay, from y from the x-axis. Now how far it's from the x-axis, we'll be calling that as x. Okay, it is at a distance x from, so we'll write this coordinate as x coordinate. Now first of all, since as far as our area element is concerned, in order to if you move this area element up, or if you move and then you move it down, it will define the total area, but its translation will be along the y-axis. Okay, therefore selecting an area element in this way will give you the y coordinate of the centroid. Okay, that is, I mean to say, let's first find the y coordinate of the centroid. We define the y coordinate of the centroid is defined as, the definition, the formula for is integral y into dA divided by integration of dA. Okay, integral dA, that is equal to integral y, it is the y coordinate of the center of our area, that is y, into dA. As far as dA is concerned, our dA is equal to b dy. B into dy is our dA, divided by integral dA, that is integral b dA is equal to b dy, that is we write b dy. Now here the variable of integration is y, and our y varies from y is equal to 0 to y is equal to h. Okay, because we have to make this small area traverse the entire area. Okay, that is, our value of y will start from 0 and will go to h. This is the lower and upper limit of our y, because our area varies from y is equal to 0 to y equal to h. Our limit of integration will be from 0 to h. Same is the case here. For in this dy is the variable of integration, so its limit goes from 0 to h, which is equal to, since b is constant, it will come out of integration, so it is b. Then we are left with y dy, integral y dy is equal to y square by 2, and the limit of integration is from 0 to h, divided by integral b dy. B will come out of integration. Integral dy is y, going from, limit of integration is from 0 to h, which is equal to, b and b will cancel, so substitute the value of h, it will be h square by 2 divided by h, which is equal to, that's equal to h square by 2 multiplied by 1 by h, which is equal to h by 2, which is equal to h by 2. What does this mean? As far as the y coordinate of the centroid is concerned, we are getting the y coordinate of the centroid is at a distance of h by 2, is at the center. So it means, if you are asked, we have a rectangle, what is the y coordinate of its centroid? Its y coordinate of the centroid will be half the value of h. Okay, it will be h by 2. Okay, now we have to find the x coordinate of the centroid. So I hope you understood how we find the y coordinate of the centroid. So I will write here the y coordinate of the centroid of the rectangle is equal to h by 2. We'll write here this is equal to h by 2. Now let me talk about the y coordinate of the the x coordinate. Let's find out the x coordinate of the centroid. How we find the x coordinate of the centroid? Let me erase this one. Let's find out the x coordinate of the centroid. In order to find the x coordinate of the centroid, let's find the x coordinate of the centroid. Now, in order to find the x coordinate, so we have to move in this direction. Okay, so x coordinate will be along the x-axis. So as far as our area element is concerned, our area element that we select should traverse in this direction. Okay, so as far as the area element, in order to find the x coordinate, we'll take an area element like this. We'll take a small area element, but this area element will be in this direction. Okay, in order to find the x coordinate, our area has to traverse along this axis. So we'll have our area, element like this. Okay, and we'll make this area element traverse in this direction along x-axis. Okay, so this area element, as far as this its height is concerned, is h, and as far as its thickness is concerned, we suppose that its thickness is very small. Let's call this as dx. Okay, now as far as our small area dA is concerned, our small area dA will be equal to this small area is in the form of a rectangle. Okay, it's in the form of a rectangle. Therefore, as far as its its area is concerned, its area will be equal, yes, its area will be equal, dA is equal to h into dx. So dA now for us is equal to h into dx. Our area is traversing in this direction. Let's suppose the center of this area is at a distance x, from the y-axis. Its x coordinate of the center of this area is x. Therefore, we can write the x coordinate of the center. See, be careful writing the x. You have to see in which direction is your area element traversing. The x coordinate of the centroid will be equal to integral of x dA from this definition, integral x dA divided by integral dA, that is equal to the center of our area dA is at a distance x, so this will be integral x, and as far as dA is concerned, dA is equal to h into dx. We'll write this as h into dx divided by integral dA. Our dA is equal to h dx. We'll write this as h dx. Okay, now look, our variable of integration in this case is x-axis, and our x varies from x is equal to 0 to x is equal to b. So lower limit of integration is 0, upper limit of integration will be b. So variable of integration here again is x, so x varies from 0 to b, which is equal to, this h will come out. This is integral x dx is equal to x square by 2, and the limit of integration goes from 0 to b, divided by integral h dx is equal, integral h will come out, integral dx is x going from 0 to b, which is equal to, this h and h will cancel. This is b square by 2 multiplied by 1 by b, which is equal to b by 2. So it means, as far as the x coordinate of the centroid of the rectangle is concerned, that's equal to b by 2. The y coordinate of the centroid is equal to h by 2. The y coordinate of x coordinate of the centroid is equal to b by 2. It means we can directly now say we have a rectangle, we have a rectangle, we have a rectangle, okay, its height is h, its width is b. Where is its centroid? You will say it is centroid is along x-axis you have to move to a distance of b by 2, that is half of the b. Along y-axis you have to move to a distance h by 2, half, that is here. Therefore, this is the centroid. This is the centroid. Its coordinates are b by 2. Its coordinates are b by 2, comma h by 2. These are the coordinates, x and y coordinates of the centroid. So if you look here, as far as the centroid is concerned, for a rectangle, the centroid lies at its geometrical center, okay? Because b by 2, comma h by 2 is also the center of this rectangle. So it means for a rectangle, the centroid lies at the geometrical center. Okay, you should remember, for a rectangle, the centroid lies at the geometrical center. This is one thing. Second is, sometimes you can bypass these integrations, you can bypass these definitions. If you are given areas and you are asked to find the centroid of the areas, you can bypass easily, you can bypass these integrations and you can directly say where is the centroid. The question is how. See, as far as the centroid is concerned, from the centroid of this rectangle we can obtain one more inference, we can obtain one more corollary, what we can say. If you look at the centroid of the centroid of the rectangle is at a geometrical center. Okay, let me draw an axis. Let's draw an axis through this parallel to y-axis. Let's draw an axis parallel to y-axis through this centroid. Okay, if you draw an axis parallel to y-axis through the centroid, okay, as far as this axis is concerned, this axis divides the rectangle into two symmetrical portions. Okay, that is, we are passing an axis parallel to y-axis through the centroid, and we are finding that this axis is dividing our rectangle into two symmetrical rectangles, into two symmetrical portions. Let's take one more axis, but now we'll take it parallel to axis passing through the centroid. That is, let's take an axis passing through the centroid but parallel to y-axis. If you look at this axis, let me define it. Let me call this as axis 1 and let me call this as axis 2. If you look at the axis 2 is also dividing the rectangle into two symmetrical portions, the top portion and the bottom portion. Okay, again I am repeating, we have drawn an axis parallel to y-axis passing through the centroid. It divides our rectangle into two symmetrical portions. I will call that symmetrical portion on left side represented by double dash, symmetrical portion on the right hand side defined by double dash. If we pass one more axis through the centroid, but this time parallel to x-axis, it divides our rectangle into two symmetrical figures, the top one and the bottom one. Both the top portion and the bottom portion are the symmetrical portions. Okay, so it means as far as the centroid is concerned, look, the centroid is at the point of intersection of these two axes, and these two axes are called axes of symmetry. These two axes are called axes of symmetry. This is important. These two axes are called axes of symmetry because these are the axes which are symmetrically dividing our area, and the point of intersection of these axes of symmetry is our centroid. Our centroid lies at the point of intersection. Our centroid lies at the point of intersection of these axes of symmetry. So what we are obtaining from here, that for a given plane area, the centroid lies at the point of intersection of the axis of symmetry. This point should be noted. That is, for a given plane area, the centroid lies at the point of intersection of axis of symmetry. The point of intersection of the axis of symmetry represents our centroid. Okay, so if you have any area, for example, I will give you, let's take an area, let's take an eye cross section, let's take an eye section. For example, if you have a section like this, you have a section, it's in the form of an eye. Let's say it's like this. If you are asked where is the centroid, of this I section, we are given that this portion and this portion have same area, okay, and this portion is in the form of a rectangle, okay. This portion and this portion are same, dimensions are same. So what we do, we will look for the axis of symmetry, okay. Look for the axis of symmetry. If you draw an axis through exactly the center, if you draw an axis like this, it symmetrically divides our area. If you draw one more axis, it symmetrically divides our area into two symmetrical parts. So we say the point of intersection, we will say that this point of intersection, represents our centroid, okay. So without doing any calculation, you can exactly say where the centroid lies. The centroid lies at the point of intersection of the axis of symmetry. So from here we can get two definitions. The first one is, in order to find the x and y coordinates of the centroid, we can use the formulas that x bar is equal to integral x dA divided by integral dA, and y bar is equal to integral y dA divided by integral dA. These are the formulas for finding the x and y coordinates of the centroid. This is one thing. The second thing is, the second way of finding the x and y for planar areas is, you look for the axis of symmetry, and the point of intersection of the axis of symmetry will represent our centroid. Let's solve few more problems in the coming classes. Thank you.